At standard pressure, the chemical element helium exists in a liquid form only at the extremely low temperature of -269 degrees Celsius. Its boiling point and critical point depend on which isotope of helium is present. The common isotope helium-4 or the rare isotope helium-3. These are the only two stable isotopes of helium. See the table below for the values of these physical quantities. The density of liquid helium-4 at its boiling point and a pressure of 1 atmosphere is about 0.125 grams per cc, or about 1/8 the density of liquid water. Liquefaction. Helium was first liquefied on July 10, 1908 by the Dutch physicist Heike Kamerlingons at the University of Leiden in the Netherlands. At the time, helium-3 was unknown because the mass spectrometer had not yet been invented. In more recent decades, liquid helium has been used as a cryogenic refrigerant, and liquid helium is produced commercially for use in superconducting magnets such as those used in magnetic resonance imaging, nuclear magnetic resonance, magnetoencephalography, and experiments in physics, such as low-temperature Mossbauer spectroscopy. Characteristics. The temperature required to produce liquid helium is low because of the weakness of the attractions between the helium atoms. These interatomic forces in helium are weak to begin with because helium is a noble gas, but the interatomic attractions are reduced even more by the effects of quantum mechanics. These are significant in helium because of its low atomic mass of about 4 atomic mass units. The zero-point energy of liquid helium is less if its atoms are less confined by the neighbors. Hence, in liquid helium, its ground state energy can decrease by a naturally occurring increase in its average interatomic distance. However, at greater distances, the effects of the interatomic forces in helium are even weaker. Because of the very weak interatomic forces in helium, this element would remain a liquid at atmospheric pressure all the way from its liquefaction point down to absolute zero. Liquid helium solidifies only under very low temperatures and great pressures. At temperatures below the liquefaction points, both helium-4 and helium-3 undergo transitions to superfluids. Liquid helium-4 and the rare helium-3 are not completely miscible. Below 0.9 Kelvin at the saturated vapor pressure, a mixture of the two isotopes undergoes a phase separation into a normal fluid that floats on a denser superfluid consisting mostly of helium-4. This phase separation happens because the overall mass of liquid helium can reduce its thermodynamic enthalpy by separating. At extremely low temperatures, the superfluid phase, rich in helium-4, can contain up to 6% of helium-3 in solution. This makes possible the small-scale use of the dilution refrigerator, which is capable of reaching temperatures of a few millikelvins. Superfluid helium-4 has substantially different properties from ordinary liquid helium. Data. Gallery.